Good morning, students.
Good morning, sir.
How was your night?
Fine.
You're welcome to this chemistry class this morning, or this afternoon, pardon. We are going to discuss the chemistries of hydrogen under the subtopic properties of hydrogen today. That is physical and chemical properties of hydrogen.
Sir.
Yes.
Is this what you taught us in the YouTube class?
Pardon? I can't hear you well.
Sir, is this what you taught us in the YouTube class?
I taught you chemistry, the laboratory and physical laboratory and industrial preparation of hydrogen. But today, the topic today is physical and chemical properties of hydrogen, then uses of hydrogen and laboratory tests for hydrogen. So it's a subtopic under the chemistries of hydrogen. What we taught last time is all about how to prepare hydrogen both in the laboratory and in the industry in a large scale. Do you understand?
Yes, sir.
Okay. But should there be any question from the last class, you are free to ask, then I will respond to it.
Did you get our email?
Okay. Now, let us pray before we start.
Okay, sir.
Can somebody pray for us, please?
In Jesus' name.
Yes, sir.
Amen.
Father Lord, as we start the class, we understand all what our teacher just, Father Lord, may your spirit guide us all to this
Amen.
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 Amen. All right. Thank you for the prayer. Like in our last class, we discussed the sources of hydrogen. Then we talked about the isotopes of hydrogen. We said that hydrogen has 3 isotopes. The ordinary hydrogen, the name is protium. The other isotope is deuterium and tritium. The tritium is radioactive in nature. All of them has just 1 electron. Sorry, just 1 proton, 1 electron, and different numbers of neutrons. We say that hydrogen can be prepared in the laboratory. Hydrogen can also be prepared industrially from the coal, from the water gas, and then from the natural gas. These are the industrial preparation of hydrogen that we discussed the other time. The water gas, we said, is the mixture, the equal volume of carbon dioxide and nitrogen gas. We use it to prepare hydrogen in a large scale industrially. Then today we are going to talk about the physical and chemical properties of hydrogen. Let's start with the physical properties of hydrogen. One of the physical properties of hydrogen is it is a colorless, odorless, and tasteless gas. The second one is hydrogen has a very low boiling point of about -253 degrees centigrade. Number 3, hydrogen is relatively insoluble in water, and that is why it can be collected over water in the laboratory during the preparation using tetraoxosulfate 6 acid, even hydrochloric acid. So we collect it by the upward delivery and downward displacement of air, because it is lighter than air, and as well, it is insoluble in water. Then property number 4, physical. hydrogen is 14.4 times less dense than air. This one is also talking about the reason why we can collect it over water in the laboratory, during the laboratory preparation. That is, hydrogen is less dense than air. Then property number 5, hydrogen does not support combustion. Hydrogen does not support burning, though it burns in air to produce steam, but it does not support burning. Another physical properties of hydrogen, we have it is highly inflammable, highly combustible, highly flammable. Therefore, we handle hydrogen in the laboratory with a very great care. Then, hey, students, please, I don't want to mute you because I want you to be asking questions as I'm teaching, then I will be responding and I will ask you questions too. But if you want to make noise by leaving the background noise in your house to disturb the class, I will mute all of you, and that should be the implication. Do you get me right? Student, do you get me right? Hello, students. I want all of you to silence all the background music, any form of noise, sound of any kind in your house, please. Do you get me right? Then
Yes,
you
sir.
put on your video as well so that I can see your faces, and you unmute yourself so that you can ask me relevant questions, and I too will be asking you questions. Do you understand? All right. So please, you have to keep quiet, listen very well, so that you can ask questions at the end of the class. So thank you. Now, talking about the chemical properties of hydrogen. I've explained the physical properties of hydrogen, and if you still want explanation, you can still ask. Okay, look at my slides for the physical properties of hydrogen. Hydrogen is colorless, odorless, and tasteless. It has a very low boiling point of minus 253 degrees centigrade. Hydrogen is not soluble in water. And I said that is why we collect it over water in the laboratory during preparation. Collect it by the upward delivery and downward displacement of air. It is less dense than air. It does not support combustion, but it burns in air. That is oxygen, with a very nice blue flame to produce steam. And it is highly inflammable. These are the physical properties of hydrogen. So let's look at the chemical properties of hydrogen. Chemical properties of hydrogen. The chemical reactions of hydrogen arise from the fact that it can donate each single electron to form a positive ion. It can accept electron to give a duplex structure to form a negative hydride. And it can share electron with another atom to form a covalent molecule to attain the duplex structure of noble gases. So these are the reasons for which hydrogen react with other elements to form compounds. Now, hydrogen has just one electron in each orbital, just one orbital with one electron. It can lose that electron to become positively charged. Then you have the hydrogen ion. And as well, it can accept just one electron to attain the duplex structure, so that it will become stable like other group 8 elements. And the same hydrogen has the ability to share electrons with one another to form a molecule, hydrogen gas. So let's look at the other chemical reactivity of hydrogen. Number 1, we have the hydrides
Please go
of
to the
hydrogen.
previous
Please
slide.
go back to the previous slide.
I cannot see your slide.
You cannot see my slides.
Yes, sir.
Are you sure the problem is not your phone or your gadget that you are using? I don't know whether you are using laptop or phone. If other students can see the slide and only you cannot see it, it means the problem is from you. Can you see it now?
Please go back to previous slide.
I will share the slide so that you can see it very clearly. All right.
Go back to previous slide.
See the physical properties of hydrogen displayed. Engineer Masoi, can you see it very well?
Yes, sir.
Okay. All right. Read out the physical properties of hydrogen on the slide for us. Yes.
It is a colorless and tasteless gas.
Good.
Boiling point of
Number 3.
9%. It is relatively insoluble in water.
Number 4.
It has 44 times less dense than air.
Good of you. Number 5.
It does not support combustion.
Number 6.
It is highly inflammable.
God bless you. Inflammable. Yes. Remember, if we say that hydrogen does not support combustion, that doesn't mean that hydrogen does not burn. Hydrogen burns in oxygen to produce steam. Then the condensation reaction of the steam gives us water. Do you understand?
Yes.
All right. Let's move on to chemical properties of hydrogen. There are 3 major points there on this slide under these chemical properties of hydrogen. Number 1, I said, hydrogen can give out only its single electron to become positively charged. Do you understand? Because it has just 1 electron in its orbital. And as well, it can accept electron from many other elements, e.g. group 1 element, alkaline metals, so that it will become negatively charged. Then you have the hydrogen ion as well. Then we say that hydrogen can donate electron for sharing with one another to form a molecule of hydrogen gas. Based on these 3 characteristic behavior, the ability, the potential of hydrogen, then hydrogen react with other elements to form varieties of compounds. Then number 1, we have the hydride of hydrogen. Hydride of hydrogen, we have the negative hydride and the positive hydride of hydrogen. Then under the hydride, under the positive hydride, for example, metallic hydride, e.g., hydrogen is highly electronegative and form ionic hydride.
Please come again. You say under the positive or under the negative?
Under the positive now. Hydrogen forms a hydride with group 1 elements. I use group 1 element here, that is sodium and lithium.
Yes.
Sodium react with hydrogen to form sodium hydride. You can see the equation for this reaction here. In my explanation, I said hydrogen react with alkaline metals, that is group 1 element. Remember, all group 1 elements have one electron in their outermost shell, the orbiter. And in this case, they can give out that one electron they have to form ion. And the hydrogen that just needed one electron to attain the duplex structure, we accept it. And it will become a hydride of that element. E.g., we use sodium from group 1 element. Sodium ion react with hydrogen ion to produce sodium hydride. Remember, all group 1 elements are strong electropositive elements. All group 1 elements are strong electropositive elements. The number 1 element in group 1 is called what? The lithium. Hydrogen also reacts with lithium. The same way it reacts with sodium, potassium, and cesium. Then hydrogen combined with lithium to give us lithium hydride. Equation for the reaction is shown below. 2 molecules of lithium react with 1 molecule of hydrogen gas to give us 2 molecules of lithium hydride.
Please go to the previous note.
I repeat. Ss2 students. Ss2 students. Can you keep quiet and concentrate?
Please go through the previous note.
Isaac Newton. If you did not keep quiet, I will mute all of you. All right. Let's move on to the non-metallic hydrides. We have just explained the metallic hydride. Metallic hydrides, we use all group 1 elements to discuss or describe the reactive nature of hydrogen to form the hydrides with metals. Then the non-metallic hydrides, group 7 elements need.
Sir, is this non-metallic still under the positive?
Yes, look at hydride of hydrogen. We have metallic hydrides. When you are talking about the metallic hydride, it is hydrogen atom that accept electron from metals.
Mommy, please, that side is dark.
Ene?
Sir, I'm hearing you.
Very well.
Yes, sir.
Okay, what I'm saying is this. Under the metallic hydrides, hydrogen accepts electrons from group 1 element, e.g., lithium to form lithium hydrides, sodium to form sodium hydrides, potassium to form potassium hydride. Remember, all group 1 elements have one electron in their outermost orbiter. That 1 electron, by the time they share it with hydrogen, hydrogen accepts the electron to become negatively charged. Do you understand? Hydrogen raised to power -1. Then, when you are talking about non-metallic hydride, it is hydrogen that is giving out electrons. Do you understand this?
Yes, sir.
Yes,
Pamela?
Yes, sir.
Very well.
Yes, sir.
Okay, I repeat. Hydrogen form hydrides with both metals and non-metals. And we categorize these under 2 major headings. We have the metallic hydrides and non-metallic hydrides. Under the metallic hydrides, hydrogen accepts electrons from metals. Do you understand? To become negatively charged and form a metallic hydride. Then under non-metallic hydride, hydrogen give out electron to non-metals, e.g., group 7 elements that needed just one electron to attain the octet structure. In this case, hydrogen becomes positively charged. Pamela, you are laughing. Hydrogen becomes positively charged because remember, in our redox chemistry, redox reaction, any element that gives out electron becomes what? Positively charged. Why any element that accepts the electrons becomes negatively charged. Electron donor becomes what? Electrons donor becomes positively charged. Correct. Then electron acceptor becomes
Negative.
Negatively charged.
that is very good of you.
Thank you.
By the time you remember that, okay, any species that accepts
Negatively
electrons
charged.
becomes negatively charged. Why that donate electron become negative, positively charged? Then you should understand the hydride of hydrogen that we are talking about, both metallic and non-metallic hydrides. So please, you shouldn't be confused about these two types of hydrides we are talking about. All right. Now, let's move on to another chemical properties of hydrogen. Though still on the hydride. Now, we say that non-metallic hydrides, when hydrogen give out electron, any non-metal, e.g. group 7 elements, they form a covalent compound. Non-metallic hydrides, hydrogen forms covalent compounds with less electropositive metals, e.g. aluminum, and with non-metals. These are covalent hydrides. The reaction here is very, very spontaneous. And we can see example below. What we mean by this spontaneous reaction? A spontaneous reaction is any chemical reaction that can take place on its own without any external factor like catalyst, light, etc. Yes, a reaction that can take place on its own, e.g. the melting of glucose in your mouth is a good example of spontaneous reaction. Another example is rusting of metal. Another example is the reaction of the oxygen with your blood to form oxygenated blood. But let's look at the reaction shown below. If you look at my balanced equation, I have 1 molecule of fluorine. Yes. A fluorine gas react with a hydrogen gas to give us a hydrogen fluoride. A hydrogen fluoride is an acid anhydride because it dissolves in water to give us an acid. Remember, group 7 elements are all non-metals, but they are the most reactive non-metals. We call them the most electronegative metals, sorry, non-metals. Now, when fluorine turns to react with hydrogen, because hydrogen is less electronegative than the fluorine, and both of them are donating electrons for sharing. Hydrogen donates, fluorine donates for sharing. Fluorine will now dominate hydrogen, and it will obtain about 3/4. That is 3/4 of the electron to be shared. Therefore, the direction of the bonding will be towards fluorine, leaving little fraction for the hydrogen to obtain. Therefore, the reaction becomes unsymmetrical, though the compound form is a covalent compound, which is hydrogen fluoride. But the bonding, the covalent bonding in between the hydrogen and fluorine is symmetrical. Do you understand? What this means is that the electrons that both of them are sharing are not being shared equal. Despite that, both of them donate equal. It's just like you and your friend. By the time you have 50 naira and your friend, maybe one of your friends has 50 naira and you want to buy egg roll. Then it's okay, let's go to the tuck shop to buy egg roll. An egg roll is 100 naira. Both of you now buy one egg roll with 100 naira being donated 50-50 by both of you. But when you want to settle down and eat that egg roll, one of you will now cut a lion's share, 3/4, and leaving the little one for the other. Example, Ezra and Ayuba. Do you understand? Because Ezra has more power than Ayuba, and that power is called electronegative power. Electronegativity is the potential, the ability of an element to accept electron from another element. Do you understand? The ability of Ezra to dominate Ayuba will now enable him to share the egg roll 3/4. Do you understand? And nothing will happen. Therefore, the sharing here is asymmetrical. It is not being shared equal. Despite that, both of you donate equal amount of money to buy that egg roll. That is what happened between the hydrogen and fluorine. Why? Because hydrogen is less electronegative, while fluorine is highly electronegative. In fact, the most electronegative element on Earth is fluorine, followed by chlorine. Ene ochai ozofu spate. Will you keep quiet there?
I'm not even talking.
There is no also.
But you are opening mouth. I saw you opening your mouth. Please keep quiet and ask relevant
That my
questions.
video is not even on.
Your video is.
Let's shake his face one.
All right.
Quiet.
All right. Look at the reaction between the chlorine and hydrogen. Chlorine reacts with hydrogen to form the hydrogen chloride gas. Just like the formation of hydrogen fluoride gas, you also have hydrogen chloride gas. This is the demonstration of what? Of hydrides. Remember, you call it hydrides. We have metallic hydride and we have non-metallic hydride. The non-metallic hydride, example, hydrogen fluoride, hydrogen chloride, hydrogen iodide. Why the examples of metallic hydride, we have lithium hydride and we have aluminum hydride. We also have potassium hydride as well, sodium hydride also. Do you understand these chemical reactivities of hydrogen now?
Yes, sir.
That is very good. Number 3. Hydrogen reacts with molten sulfur to form hydrogen sulfide, which smells like a rotten egg, and it also reacts with nitrogen to form ammonia. I repeat, number 3 chemical properties of hydrogen. Hydrogen reacts with molten sulfur to form hydrogen sulfide, which smells like a rotten egg, and it also reacts with nitrogen to form ammonia. A question for the reaction. It's better you follow me. Stop making noise and follow me. I will ask you with chemical equation only. Outline 5 chemical properties of hydrogen. Do you hear me?
Yes, sir.
Yes, sir.
I'm giving you expo. With chemical equation only. With chemical equation only. outline 5 chemical properties of hydrogen. If you are expecting any WAEC, any external exam board to ask you question, mention physical properties of hydrogen, uses of hydrogen. In fact, you are deceiving yourself. Anytime you are studying all these metals and non-metals, what you should know is try to know that the chemical reactivities of elements is what any chemist is interested. Do you understand? Now, looking at the question for the reaction. 1 mole of hydrogen gas, 1 mole of hydrogen gas reacts with 1 mole of sulfur to give us hydrogen sulfide. Remember that sulfur is solid, but by the time you add water to form a molten form of it, then we said molten sulfur. Molten sulfur react with hydrogen to form hydrogen sulfide, which smells like a rotten egg. If you come to the laboratory, we'll demonstrate this so that you will see it practical. In practical terms, we use these hydrogen sulfides to carry out most of the laboratory tests. Do you understand? Now, or practical. Then 2. 3 molecules of hydrogen gas react with nitrogen gas to form 2 molecules of ammonia gas. 3 molecules of hydrogen gas react with 1 molecule of hydrogen to form 2 molecules of ammonia gas. That is, hydrogen react with molten sulfur to form hydrogen sulfide and also with nitrogen to form ammonia. Remember, ammonia is a heavy chemical. Ammonia is a heavy chemical. And what are heavy chemicals? Heavy chemicals are those chemicals that are produced in a very large quantities for the manufacture of other substances in the industry. For example, in the roofing sheet industry, they make use of both hydrochloric acid and tetraoxosulfuric acid in a very large scale, like ammonia. So we call them heavy chemical. Ammonia is a good example of heavy chemical. Then number 4, chemical properties of hydrogen. Hydrogen is a very strong reducing agent. It is a very strong reducing agent. Ochapa Ann. Ochapa Ann. Ochapa, I'm calling you. Can you tell us what reducing agent means? What is a reducing agent? Ayuba.
Sir.
What are reducing agents?
Sir, reducing agents are agents.
Sir. Ayuba, you don't want me to talk to you again.
Reduce.
Sir, let me answer.
Put on your video, please. Yes? Can somebody help him? Ochapa?
Yes, is or compound.
What are reducing agents? Mention two good examples of reducing agent other than hydrogen that you know. Yes. Isaac, can you define reduction for us? Reduction means addition of hydrogen to a substance. Therefore, a reducing agent is any substance that removes hydrogen from a compound. Do you understand? Now, Oxidation is the addition of hydrogen to a substance. Now we are talking about reducing agent here. If we say that hydrogen is a good reducing agent, it means hydrogen being a good reducing agent has the ability to extract oxygen from another compound. If you look at this equation below, lead 2 oxide react with hydrogen gas, then you have 1 molecule of lead solid and 1 molecule of steam. Remember, from your reactants, there is no oxygen attached to the hydrogen atom here. But at the product side, you have oxygen being attached to the hydrogen. Means hydrogen removes oxygen atom from lead 2 oxide to form lead solid and a molecule of steam. That is a reduction reaction. Do you understand? Mr. Ayuba, do you understand?
Yes, sir. Yes.
Edward Mundy, do you understand this equation for this reaction?
Yes, sir.
Pamela, what about you?
No, come again.
I should come again with the explanation of reduction.
Yes, sir.
All right, we are saying that the number 4 chemical properties of hydrogen is hydrogen is a strong reducing agent. Being a strong reducing agent, it has the power to extract oxygen atom from another compound. Looking at the equation for this reaction, lead 2 oxide reacts with hydrogen gas to form steam and the lead solid. So, from the reactant, there is no oxygen attached to the hydrogen. But at the product side, oxygen is now attached to hydrogen to form steam. You understand? Meaning, hydrogen has the power to extract oxygen atom from the lead 2 oxide. For example, when Pamela and Ibrahim Faith, a giant girl in my class, donate, not even donation, they even donate together. Now, Pamela want to go to the talk shop and buy a group. Ibrahim Faith say, let me keep you company. Then at the talk shop, Pamela used her money to buy a group. When they now return back to the class to settle down, then Ibrahim decides to collect the egg group from Pamela. And Pamela has nothing to say. Why? Because if Pamela say anything to Ibrahim Faith might beat her up. Why? That is the power of reduction. Power to collect forcefully. Do you understand?
Bullying.
All right. I said reduction. Reduction or reducing power of hydrogen means hydrogen has the power to extract oxygen from another compound, and by the time it's been added to another substance, then we said reduction has taken place. Reduction means addition of hydrogen to a substance and removal of oxygen from a substance. While oxidation means addition of oxygen to a substance or transfer of electrons or removal of hydrogen from a substance. I'm taking you back to redox reaction, please. All right. Now let me explain the second equation here. We have 3 molecules of tetraoxide of iron react with 4 molecules of hydrogen gas to give us 3 molecules of iron solid plus 4 molecules of steam. This reaction is a reversible reaction. That is why you can see the double arrow in this equation here. And then, can you see this double equation here showing that the reaction is reversible? All right, thank you. Another chemical properties and other chemical properties. Now, we have other reduction reaction are copper 2 oxide react with hydrogen gas to give us the copper solid and steam. Zinc oxide react with hydrogen gas to give us zinc solid and steam. Iron 3 oxide react with 3 molecules of hydrogen gas to give us 3 molecules of steam and 1 molecule of iron, 2 molecules of iron.
Can we go back to the
Please
previous
go back to the
slide?
2 previous slides.
All right, I'm taking you back there.
The other one.
Other reduction reaction. Please, we are going to send the note to you. Don't bother yourself to get everything copied. You understand?
No problem.
You can only get the
All
summary.
the time, oh. There's not all the time that you guys send the notes.
It's all the time. Check your
not
mail
all the
well.
time.
Or your WhatsApp very well. The platform, you will see. All right, let's look at another chemical properties. Hydrogen bonds in air with pop. Hello?
Hi.
Hydrogen bonds in air with pop sound and with formation of water, which is steam. As you can see in the equation below, is a good chemical properties of hydrogen. Let's look at the compounds of hydrogen. Don't worry, we are going to send this one. Compounds of hydrogen. When hydrogen combines with other elements, it forms hydride. Number 1. We have talked about this. Please let me move on to uses of hydrogen. Uses of hydrogen. But let me look at compounds of hydrogen first.
So we don't have all the time, Fa.
Joy, keep quiet.
Don't have all what?
Please, you push, leave and speak our mind. Which one is keep quiet?
I don't know. So what if I beg you just keep quiet? I'm saying that instead of going to fast, what if
listen, students.
Yes,
I'm listening.
Sir?
Repeat what you just said. That you don't have.
There is not me that is talking.
That is me. It's me that.
There is Joy that is talking. It's not me.
Joy.
Sir.
Joy. You say
Yes,
you don't
sir.
have all the
Sir,
time. So.
Yes, sir.
You mean these teachers that are here trying to put you through so that you don't just stay.
Sir, what I'm saying is that you are going too fast. I'm saying you are going too fast.
Is that the meaning of you don't have all the time? What else are you doing apart from what you are doing right now, which is chemistry class?
She means that there's no time to cover everything.
Oh, I'm going too fast.
Exactly, there's no time to cover everything.
All right.
If there is no time to cover
Sir, please
everything,
go
just
to
send the note.
It's better you go
Please
slow so
go
that
to
we
page
understand.
2 and
Exactly,
3.
let him go slow so that we
Okay,
understand.
that is okay. That
Then we
argument is
understand
okay.
anything.
You have the note so that you have all the time.
Please, it's okay.
Sir, go to page 2 and 3.
Hey, listen. Are we together now?
Sir, go through page 2 and 3.
Okay. Let me go back, please. Now, let me take you to the uses
Sir, go
of
through page 2
hydrogen.
and 3.
Even if I will take you back there to that slide, let us finish this use of hydrogen, then the laboratory test for the hydrogen. Then I'll give you some classwork and assignment before we can now go back to the previous slide. All right, uses of hydrogen. Number 1, hydrogen is used in the synthesis of ammonia.
Sir, page 2 and 3.
Just follow me, please. I'll take you back there. Uses of hydrogen. Uses of hydrogen. Hydrogen is used in the synthesis of ammonia in a large scale. Then number 2, hydrogen is used in the hardening of vegetable and animal oils for the manufacture of margarine, candles, soap, and many more substances. Hydrogen is used to inflame airships and balloons Hydrogen is used in the manufacture of oxyhydrogen flames for cutting and welding metals in industry. I repeat, hydrogen is used for the manufacture of oxyacetylene flame. Remember, when hydrogen reacts with ethane, each member 2 of ethane homologous series, it forms oxyacetylene flame and bond in oxygen. Then it gives us a very nice bluish flame, which is very strong enough to cut and weld metals in industry. Then number 5, just listen to me. I will send you the note so that you can go through the note, then you remind yourself of my explanation. Do you understand? Then if you have any question, you can now ask through my email or WhatsApp number. Right? Hydrogen is used in the synthesis of methanol. Example, methanol, ethanol, propanol, in fact, all anal groups. Whether alkanals and alkanols homologous series, hydrogen is one of the active ingredients making them. And you know what ethanol is. Example, illicit gin called ogogoro. Now, number 6, gaseous hydrogen is a constituent of coal gas and water gas. And liquid hydrogen is used as a rocket fuel. Remember, in WAEC, if they ask students to mention maybe 1 or 2 uses of hydrogen, some students used to just mention one of the uses like this. Hydrogen is used as a rocket fuel. Examiner will not mark it right for you. You can put it like this. Liquid hydrogen is a liquid hydrogen that can be used as a rocket fuel. Do you understand?
2 and 3.
Not a dry hydrogen, not a hydrogen gas, but a liquid hydrogen.
Please go to page 2 and 3.
Masoi,
I'm done now.
I promised to go back there. Do you understand? We must go back there. All right. I have this question for you. While we are trying to round up the class, then I have this evaluation for you. You will still ask a question. Don't worry, we are together. Number 1, discuss the reducing properties of hydrogen.
Sir, please send this note if you're not able to do this evaluation.
And then come again, please.
I said, sir, please send the note. If not, the evaluation will not be able to do.
I will send you the note, don't worry.
Sir, that's what you always used to say.
But is this question very difficult? Is this question difficult?
Very.
Number 1, discuss the reducing properties of hydrogen. Number 2, how do you test for hydrogen in the laboratory? Number 3, highlight 5 uses of hydrogen. Number 4, with chemical equations only, outline 3 chemical properties of hydrogen. With chemical equations only. Who is that person? Please, will you stop that?
Please go back.
I have assignment for you. Number 1, mention 5 uses of hydrogen. Number 2, mention 5 physical properties of hydrogen. Number 3,
Please go back to the evaluation.
I will go back there, but get this one first. Thank you. Number 3, describe a test for the presence of hydrogen in the laboratory. Then number 4, with chemical equation only, outline 3 chemical properties of hydrogen. Now,
Sir, please,
copy this assignment before I can take you back to the slide that you want.
Send it to the notes.
number.
I should do
I'll
what?
copy it.
Okay.
I will send the notes.
I will send the note to you. Don't worry, please.
Are you sending the assignment?
I'll go back to the evaluation now.
Yes. Okay. See the evaluation here.
So how are we going to submit the assignment?
You will submit the assignment to the email address ogolomatthew@gmail.com. on the first test.
Jesus, sir, the evaluation.
I will go back there. Look at the test for hydrogen first.
I be draw and three.
Let me take you back to the test for hydrogen. If a lighter splint is plunged into a gas jar of unknown gas, it gives a pop sound. That pop sound indicates the presence of hydrogen in the jar. I repeat, hydrogen gas gives a pop sound when a lighter splint. Lighter splint means a glowing splint. When you dip it to the mouth of the gas jar containing unknown gas, a pop sound is heard. That sound indicates the presence of hydrogen in the gas jar. In the gas jar. Anna, do you get me?
Yes, sir.
God bless you. Now,
Sir, please, the evaluation.
then I'll send a note to you quickly, please, so that you can be able
Sir,
to.
please, the evaluation.